the SAE Speaker Series. I am Rachel Wetzel. I have my colleague Amanda Kibler here with me today. We have a few guest industrial lecturers that are going to be speaking in a little bit. We have James Shaw and Dean Case with us, and also Dawn Smolensky. First, we're going to start off with the industrial lecture program. I just want to give you guys some background on it. It was built to foster networking and in-depth learning opportunities on campus between practicing engineers and faculty and students. Now, this primary goal is accomplished through our very generous SAE Ralph Teeter Educational Fund. And what that committee does is they have put this program together to sponsor engineers to be able to travel to these universities that have SAE chapters. All right. All right, now I just want to give you a couple instructions for requesting a lecturer. I want you all to be sure that this is a benefit for SAE chapters. I know a lot of you are on CDS teams. Most of you have chapters. If you don't, that is okay. I can just reach out to me and I can help you get a chapter started. If you aren't sure if you have a chapter, just reach out. We currently have 23 very active lecturers with a wide variety of topics to choose from. So the first thing I want you to do is get together with your chapter, get together with the students that are a part of your chapter, even your faculty advisors. Go online. We have our industrial lecture program. All of the lectures are listed underneath the collegiate chapters tab on SAE.org. We have their bios. We have an abstract of their presentations up. Go through and just read over all of that. Find a lecturer that might be a perfect match for you. You don't have to pick one. You can pick more than one to invite to your campus. There is an application online that you can apply to, but if not, you can reach out to me too. That's fine. You can ask for these lectures to come in person or virtually. You could do a lecture in the fall that's in person. Maybe say you want to do one later in the spring that's virtual right before a competition, or even in the summer. You can invite as many lecturers as you want, provided that the lecturers have availability to come to your campus. And then I also wanted you to just think about maybe inviting another university. Maybe you have friends at another university down the street that you want to invite over. The lecturers love to have more than one. They love to have a room full of students to speak to. So feel free to invite others on your campus that might not be part of the chapter that might be interested. Invite faculty members, and anybody else that you might feel that could benefit from this. Invite on down. I also just wanted to mention that I will be the one who connects you with the lecturer. So feel free to reach out to me with who you want to invite. I will get you connected with them, and you'll be able to go from there to pick a date and time that works for everybody. So with that said, I want to turn it over to James Shaw. He is going to present on his topic, a little bit on his topic right now, and let's see what he has to say.
Great. Thanks, Rachel. Appreciate it. Share my screen here. All right. Can you see my screen okay?
Yes.
Great.
Looks good.
Good morning, everyone. Again, my name is Jim Shaw, and I'm one of the industrial lecturers that get a wonderful chance to travel around and visit so many amazing schools and academic institutions and meet with, I don't count how many students I get a chance to engage with, but through this program and through some of my mentoring with the Collegiate Design Series, I think hundreds, I would say. The topic that I like to talk to schools about is industry best practices in computer-aided design, finite element analysis, and computational fluid dynamics. And these are tools that we use as mechanical engineers, of which I am one, to perform all kinds of design analysis, optimization type studies. This essentially is the language for many of us in the industry who have design analysis and I'll say production release responsibilities. And these are topics that are not necessarily covered in a curricula at school. Of all the schools that I've gotten a chance to visit with, and I've got, I don't know if that's a full list at the bottom, but certainly is a very complete list of many of the schools I've gotten a chance to visit over the years. All of them have a very different approach to these simulation tools. Some schools, it is embedded into the core curriculum. Others, it is shoved into a short little maybe virtual class or an elective. And so we see students going into the industry with a wide variety of experience and understanding of the capability of these tools. So the purpose of this lecture is to get in front of the students while they're still in school and either confirm some of the things that they've learned or know about these tools, or to show them exactly how they're used in the industry. These tools are used in both academia and industry, but in industry in particular, we've got a very specific way that we leverage these tools, and they're very, very much valued. And for what it's worth, I am also a small business owner. So whenever I do a lecture, I do try to talk about product development, engineering, production support, all of our technical responsibilities within the construct of a business, of course. I like to show this picture. This is probably the second or third slide in all of the lectures that I do as an example. And I have an example here from Formula SAE in the Collegiate Design Series, an example of the changes that we've seen in mechanical engineering over the last 20 years. And yes, that's me on the left in the gray Pitt sweatshirt, and that I graduated exactly 20 years ago this year. From an engineering discipline or mechanical engineering discipline as a whole, the changes have been around, from my view anyways, the technology and tools available to us, the expectations of us by our customers, by our mentors, by managers and leadership within the organization, and the level of effort required. So to use the Formula SAE example, the car on the left, you have to design and build and test and race that, from scratch every year. The same for the car on the right. And you can see the car on the right is significantly more complex, has more parts to it. You can infer there may have been more analysis work done to it. So, there are a lot of expectations in engineering, but we see that very, very much in the Collegiate Design Series, particularly in Formula SAE. So I always like to show this to remind people that, we don't have to use CAD. We've been flying planes and driving cars long before fluid dynamic tools were available to us. A lot of these tools came out of the space race in the 60s, where we didn't have the computing power that we have now. But the tools are there. The hardware is relatively easy to get. The software is easy to get. We've got trainers and mentors like myself out there. So the expectations are changed. The tools are there. And I love how we always say that the Collegiate Design Series is a simulation of the real world. It absolutely is. And I use this as an example. And it's not just in Formula SAE, and it's not just in the mobility industry, but we do see those particularly those tools being leveraged very, very, very much in mobility, right? So every ounce counts, as they say, right? Every time we can take just a few ounces off of a part that has to move, that is powered in some way, internal combustion or EV, every ounce counts. There's a cost to that. And so these tools are used pretty early on in the development process, right? Before we prototype, before we do any sort of tooling or production, we use these tools to predict things like performance and reliability, weight and cost savings. Almost every single design goal that we will get or design challenge that we'll get as an engineer is going to have some sort of weight quota or cost goal. And we're able to predict those in the computer long before we prototype and then release to production. And of course, this term that gets overly used, I think, in the industry a little bit right now, of optimization. Engineering has always, in my opinion, been about optimization. Mechanical engineering, I think, is a discipline where you're trying to find the intersection of structures physics, fluids physics, heat transfer, electromagnetics. There are multi-physics now. But a lot of our designs have to be optimized within those constraints. Every design is different. Every industry has their own goals, their own concerns, and every business has their own competitive advantage. And I love the Collegiate Design Series in particular, simply because that is showing the students in real world terms the challenges that we have. Now, to Rachel's point earlier, I will say that I have visited schools that are not in CDS. So I have visited schools that are not, they don't have any active teams, but they do have an active SAA chapter. And we had a phenomenal conversation about some of their senior design projects, about what they were working on in their co-ops and internships, and a desire to be in one of the CDS competitions. So to Rachel's point, you don't have to have a team to invite us to come visit. These are all real world applications and topics, even though the teams themselves really do put that to the test. For what it's worth, I won't go through all of this, but this is just a general overview of the topics that we cover. Again, I'm a former CAD administrator, so that's AKA a CAD police person, and learned a lot about working in large companies and some of the requirements. Of all of the teams, or excuse me, of all of the schools that I've visited, the most common denominator, of course, is that most of the schools have a Formula SAE team. And so we do use that as sort of a case study to walk through. And I always tell students, you are a company. You operate like a company, especially in 2022. You have members from various engineering disciplines. You have members from business schools and marketing. You really, really do. You're concerned with things like timeline and budget and recruiting. And these are exactly real world problems, but they actually get distilled down into the discipline. So having 30 members actively work on a single assembly file in CAD is a problem. It's a problem that industry figured out, decades ago, because it was there first, but these are the challenges that a lot of the Collegiate Design Series teams have as well. And then, of course, we talk about structures and fluids, which are the core disciplines within mechanical engineering, which is my background. And this lecture is completely agnostic. So, we don't cater towards any of the brands. You can see a variety of brands that you probably recognize on the left-hand side of the screen. And the reality is these tools are under the hood, no matter what color and what whoever you purchased it from, you go under the hood, the equations of state are the same. The approaches are the same. The hand calculations that we have to do to prepare, they're all the same. The methods are the same, even though each one of those companies has their own sort of different spin on it. So we try to take away some of the biases that some of those companies have. We take away the sales and marketing content. We dig right into engineering. And I get a lot of positive feedback from the class, so I think it really resonates with the students. This is also a question that I present in every single one of the lectures, and I find it really, really funny to hear some of the results, or at least some of the guesses. When I was a senior in 2002, I would say, roughly speaking, about 5% of the car was modeled in CAD. And honestly, I would say it was probably like one part. And I always ask the audience, which part do you think we chose to model in CAD? And I immediately get questions like frame and suspension and things. And of course not. You don't need CAD to design a tube chassis. We did ours with cardboard and masking tape. And you don't need it to design a kinematic suspension system. Those are all hand calculations and two-force members for the most part. So we have equations that can design those things. So CAD is really good at doing complex geometry tied to a digital manufacturing process. So in 2002, there were some digital manufacturing processes, but a state-of-the-art technology back then was 3D printing, which of course now is absolutely ubiquitous in mechanical engineering. And I think it's easy to say that every single class that every single school that I've visited has had 3D printing an active part of their product development process. But in 2002, the only CAD model that was created for the car at Pitt, which I created, was the intake manifold in plenum. Very complex geometry, tight packaging in the back of the vehicle, and it really required that complex loft feature that is available to us in CAD. Could I have done it by hand? Of course I could have, and it was done by hand long time before me. But doing calculations like cross sections and predicting things like pressure drop really helped to have CAD. And we used, again, a 3D printer, which at the time was about the size of a vending machine, and we used that 3D printer to create a mold that we're able to wrap carbon fiber around and manufacture it that way. Today, 95% of the vehicle is in CAD. And the next question to the audience is, which 5% isn't in the CAD model? And again, I get all kinds of answers like hardware. Of course, you should have hardware, nuts and bolts and washers. If you want an accurate center of gravity and you want an accurate understanding of can you fit your hand in there and can you fit a wrench in there, you're going to put the hardware in there. And we use we apply hardware to our CAD models every single day in the industry. The 5% of the Formula SA vehicle that is usually the last 5% and many times doesn't get modeled are usually the electrical cables. And nowadays that's becoming more and more important with the increase in attention to EV. So now we've got not just low voltage, but also high voltage as well. And those become very challenging. We have concerns like electromagnetic interference, EMI, EMC, conductivity, and they're getting pretty large. Copper is a heavy metal. And so again, if we want accurate CG for performance and reliability predictions, we need to have that. But in the industry, it's the same. Many companies are developing mobility vehicles, multi-physical vehicles, hardware, software, et cetera, and they may or may not model the cables. But at the absolute peak of the industry, the peak of performance, we're putting 100% of the vehicle in CAD. We have to be able to understand all of the potential design flaws or lack of optimization or even preparing for production. So, but from a Formula SA car, we're still at rough around 90-95%. And so the other thing I always talk about too is, and I won't go through this in detail, but no matter what physics you're simulating, structures, fluids, electromagnetics, mechanical engineering, electrical engineering, heat transfer, et cetera, it's generally a 3-step process. And in the lecture, I walk through where the human plays a big role, such as in pre-processing and post-processing, and where the solver and the hardware and the software plays a big role, which is mostly in the second step there in the solver step. So we talk about, time management, right? As a student, as a mechanical engineer, every time you go to work, every time you go down to the shop after class, you have a choice. Do I sit at the computer? Do I wrench? Do I build? Do I test? Do I measure? We have a lot of different tasks that we need to do as we wear multiple hats as an engineer. If we decide to sit at the computer, we again have multiple decisions. Do I sit in FEA? Do I sit in CFD? Do I do CAD? Do I do CANcalcs? Am I in Excel? Do I do homework? Research, I should say. Homework maybe, but certainly research. So you have a lot of choices to spend your time. And we have those choices in industry. So when you choose to spend your time in simulation, and I have this red arrow circle here, when you choose to spend hours and hours and hours in FEA or CFD, you have to take what you learned and go back and change the model. If you don't, you have done a complete disservice because you could have spent that time impacting the design in other ways. And again, students are the same way, right? We want to just do FEA, check the box, say, yay, we did the FEA, and move on. But you really don't want to do that because you're not giving yourself the credit of spending that time and not doing something else, right? If we have a car that's running, we test. We go out there and we get seat time and we test and we tune. But if we don't, it's a rainy day or we don't have access to it or we don't have a car that's running, then we choose to do things like sit at the computer and potentially do FEA. So be aware of the time that you spend because those are things that we think about every day as a mechanical engineer. And with that, I just want to thank Rachel for giving me an opportunity to share a few of my thoughts and concepts. I do have a screenshot here for what it's worth, Rachel. I wasn't sure if you were going to have one. I don't know if it's the complete list, but this is the list of lecturers that's on the website. And I absolutely urge anyone in the audience to go to that website. And as she said, you could ask every single one of us. You could have one come a week for, every week. Please stay connected with us on the Member Connection. And if you are an engineer or about to become an engineer, you have to be on LinkedIn. One of the most powerful things that you have, that you own through your entire career, no matter who you work for, is your network. So please get on LinkedIn, get connected with me and anyone else on there, and hopefully get a chance to see you out there in one of the lecture series. Thanks so much, Rachel. I appreciate it.
Thank you. Thank you so much for that presentation. It was great. And like he said, yeah, these lecturers, guys, they want to come. They want to help you. They want to present to you. So please feel free to look them over and reach out. If anyone has any questions, you can also drop them in the comments. Amanda's going to be moderating that. So if you have any questions for Jim or Dean or Dawn, please pop them in there and we'll get them answered for you as we go. So next up we have Dean Case.
Okay, let's see if I can get the screen share to go. Oops. Hang on. I'll switch over here to where it's actually a slideshow. Okay, got that?
Yep, looks good.
Okay, mine is the least technical presentation of any of the great speakers available. Mine is more lessons learned and a lot about motorsports and alternative fuels, where I spent my career. I joke that this is my talk is things they don't teach in engineering class, and here's the corporate head shop, but the real spirit of my talk is much more informal. So that's why I have the Simpsons animated version of myself. There's my headshot. But a lot of this, I try to have fun with this because mine is, here again, there'll be no equations in anything I talk about. This was the best review I ever got after I spoke at New York University. I like to be very optimistic, but, if you get involved in motorsports, it's you got to understand that motorsports is not necessarily what you think it is if you're looking for a career. So a lot of what I do is tell some stories from my early, all stages of my career. This is early days when I was a kid who obsessed with cars. Went to Cal Poly, was involved in their Baja program, both SAE Baja as well as we raced in the Baja 1000 and did some other off-road racing on the professional side. Ended up going to work for Mazda R&D, worked in the original Miata program, and then spent some time in Detroit, which is, if you're a car geek, it's stunning the resources if you go to work in Michigan. When you're at world headquarters of a car company like Ford, GM, or Chrysler, it's just stunning what is available to you. But I was doing a lot of SAE volunteer work there. We got a fun display for Formula SAE and Baja over at the Motorsports Hall of Fame when it was located in Novi. So I was tying a lot of things together. That's kind of, you might say, my talent is connecting the dots and helping make connections like that. Coming back to California, spent some time with Nissan, did their electric vehicle program, helped launch Nismo, and then went freelance in 2006 when Nissan decided to relocate from Los Angeles to Nashville. And I was organizing the first Formula SAE West back in 2006. So gave me a lot of opportunities to cold call a bunch of companies. And one of the things I'll explain is how SAE opened up doors. The photo over to the right in the center where you see the checkered floor, that was Vic Edelbrock Jr.'s private car collection, not open to the public. But when we asked if we could do a presentation with some SAE students there, he was more than willing to let us in there. That's the type of thing that if you just knock on the door, you're not getting in. But if you talk about SAE, you can get in. My data points, I think, similar to Jim, I've been at a lot of different schools. So a lot of times I'll make comments to the students and I tell them not to take it personally, that it's more of an aggregate of a lot of observations I've had. The students today, I believe, are graduating with more technical skills than ever before, but their communication skills are not up to the task always. So, and that's a lot of what we cover in my presentation. And talk a little bit about connections made, and I'm glad Jim mentioned LinkedIn, because I've got a great story. I won't give the whole one now, but connections that started back in 1983 with me led to an SAE student ended up going to work for NASCAR. And it was a combination of SAE connections and reconnecting with an old friend via LinkedIn. I will say on the LinkedIn front, though, make sure you put cover notes. I will, if you send me an invite with no cover note explaining where I know you or why I should connect with you, I'm going to hit ignore. I make sure my connections are basically people I actually know. And then a lot of what I get into in my formal presentation is, how you can leverage, Formula SAE or Baja for the career opportunity you're looking for. The one little thing that, we all know if you've been involved in it, that Formula SAE and Baja tends to damage your GPA a little bit, but it gains you the experience that industry wants. So a lot of times it's a matter of making sure you can get past the, what I call leapfrogging the HR. HR, the joke is it theoretically stands for human resources, but at too many companies, it stands for a huge roadblock. And so I talk about a lot of the ways to, get to the person who's empowered to say yes, not just the person who's empowered to say no. So a lot of these are topics we go into during my career presentation. And then, this is, a lot of the formula students in particular, I see a little bit more on the formula students and the Baja students are obsessed with motorsports, but they don't really understand motorsports. And they think that if they get a job, let's say an IndyCar or even NASCAR, that it's going to be a combination of what they've seen on TV and what they've done in their formula car. And they're going to be disappointed. I'm not saying it's a bad career, but we're not a pure sport. We're the Venn diagram of where sport, technology, and commerce meet. And you could have the best driver in the world, best car in the world, but if there's no money to pay for it, it just doesn't happen. And talk a little bit about the sport versus business of motorsports, and then give some examples of using LinkedIn as a research tool. You can go in there, and this is the free level. This was the example I did with the University of North Carolina at Charlotte, and the fact that I could find 150,000 of their alums, but then when you start adding in other filters like what industry are they working in, what's their job title, and where they live, you can boil that down to, I think for this school, I found them 200 automotive engineers who are still in the state of North Carolina. And 200 is a pretty manageable number. If you had 20 people on your team, you could give a list of 10 each to go out and reach out to. And those are people who already care about your program, care about your school. So it's a really fantastic research tool. A little bit of plug that, industry knowledge is more than just technical facts. It's knowing what's going on in the industry. Hopefully, since you're all SAE student members, you're reading the Automotive Engineering magazine, but pick up other ones. If you want motorsports, I recommend Grassroots Motorsports. Great way to kind of follow what's going on, both the business side and the sports side. A little plug here for what my main client is these days, SRM Motorsports, which is the series formerly known as Pirelli World Challenge. And this year we've been working with, I've been reaching out to some of the student groups wherever possible to get them to come out to the races. And it's been a challenge this year, partly due to COVID and partly due to the fact that many of our races are over the summer. So it's hard to make those connections. But if there's anybody on this who's from Florida, next week, and this is the 2023 schedule, but very similar to this year. So that next week I'll be down in Sebring, Florida, and then Indy in October. So if there's anybody who's on this webinar from Florida or in Indiana, reach out to me or reach out to one of the SAE staff members to connect with me, and we can get you there to showcase your car at a racetrack in front of racers. And then I also talk a little bit what I call the biggest failure mode is lack of follow-up, and that's where a lot of students just, they blast in a resume or send something out and then just expect magic to happen. There's got to be follow-through. And that's kind of, I have a much, much longer version of this. And my measure of success usually when I do these is whether I get really active Q&A. And, it's interesting for the schools I've gone to, Q&A has ranged from as few as 5 minutes. Not quite sure. I just didn't connect with those students. To my favorite was one school, I think Q&A, we finally cut it off after an hour and a half. And so I would encourage you. There's a stunning list of great speakers. I know some of them. Amanda Nummy, I got to see her presentation. Fabulous. Mike O'Neill has been a longtime friend. Michael Royce has got more Formula One stories than anybody you've ever met. There's some great speakers. Get them to your schools. A couple other things, though. Reach out to your local SAE section. Invite them. It's a good excuse to get industry to come there. The other things is the kind of the care and the feeding of your guest speaker. Make sure you give them clear parking instructions. The worst thing for some of us when we go to a school we've never been to is figuring out where the heck do we park? Am I going to get a parking ticket? Do I have to pay here? How do I find the room? Take care of your speaker. Please do that. That's just common courtesy. And I think SAE staff mentioned that, but reach out to some of the other groups. Invite SWE, invite SHIP, invite NSBE. We did one of the biggest events we ever did here in Southern California section is where we teamed up with our counterparts at SWE, SHIP, and NSBE, and it was fabulous. And it really strengthened all four organizations. So that's it. Can't wait to hear Dawn's talk.
Thanks, Dean. And just one more thing about, you had mentioned about the sections. we are really working hard this year to connect the chapters with their local sections this year too. So any students out there, you will be getting an email from Amanda connecting you with your section officers. Take advantage of it. They are industry professionals that have a wealth of knowledge. They can help you in any area, and you can collaborate. You can do events together. So I just really encourage you to work with your local section. We're going to get you guys connected and get you rolling this year. So
The other one, can I add one thing that when
Yeah.
you graduate, remember, join your
Mhm.
local section, get involved. I mean, we, on the section level, we try to identify the rock star students and get them involved.
Mhm.
And I don't know if, every section is different in terms of a lot of logistics. If some of the schools, I'm sure Jim and Don visit some schools that are pretty remote from industry. And for them, it may be a bigger challenge, but it's even more important for you to reach out to those connections because you are remote. If you're in Michigan, it's like every other house down your street probably has someone that works for a car company. If you're in North Dakota, not so much. So, but some of the smaller sections are superb. In fact, the North Dakota one was great when I visited them, and
Mhm.
Atlanta section's really, really strong. But there's a lot of sections that can really use an infusion of young talent.
Yeah.
So,
Yeah.
I think some of the sections you can reach by with a Zoom meeting, because I've had some that were pretty
Mhm.
remote, and I've done that, and it worked pretty well.
Yeah. Yeah.
Although they said we can't buy you lunch this way, but other than that,
That's okay though. All right, Don, well, I'll ship it off to you. Go ahead, you
Okay.
can take it away.
I need to share first, I think, right? Okay, are you seeing the slides?
Yep, looks good.
Okay, good. I'm Don Smolensky. I'm gonna do a kind of a 10-minute quick run through of my talk on the adventures and misadventures of a lubricant engineer. It's by way of a little bit of background. I have a bachelor's in chemistry from the University of Michigan at Dearborn, and I co-opted at Ford Motor Scilab in the analytical chemistry area. It took me 6 months longer to graduate, but it did an important thing. It kind of convinced me, it was a great opportunity, but it kind of convinced me that I didn't really want to be a lab chemist. And so I switched over, went into chemical engineering, did a master's at Wayne State, and found a faculty member that would take me on as a part-time PhD student at Wayne State. And which is, I was trying to do while I was working full time and helping to raise a family and coaching soccer and all that good stuff. Took me forever, but I did do it. I claim that I was close to getting retirement benefits as a student. It took me so long, but I did get there. I'm gonna find the easiest way to do this. Okay. As far as my professional history, I started out at GM Research in the fuels and lubricants area, and they gave me a project on taxi testing. Taxi testing was always good because, we'd run 100,000 miles test in real taxi service. Taxis get abused, so this is a pretty difficult kind of thing to do. And we were looking for some subtle differences in the anti-wear performance of some of the additives in the engine oil, and we were able to show some pretty interesting things. I was also involved in developing industry standard engine tests. If you go to the store, the auto parts store, and you buy a quart or a gallon of engine oil, somewhere around there you're probably going to find an American Petroleum Institute API designation. And how to get that designation, that license, you have to go through a bunch of both bench and industry standard engine tests. You have to pass those. So we were involved in that. Kind of in conjunction with that, I served on the SAE Lubricants Review Institute. It's a military committee to review engine oil submissions. So the oil suppliers would come in and submit data and parts and things to the SAE LRI to get mill approvals. And in conjunction with that, I actually was served a subpoena to go to Newark and meet with the U.S. Attorney there, the Department of Defense, and the FBI. I was a bit nervous. I had a GM attorney with me, but about a half hour into this meeting, it was clear that they wanted me as an expert witness in that criminal case, and that was really an interesting thing, and I really ultimately enjoyed it quite a bit, and it went very well with them. I further it in GM Research Fuels and Lubricants, I worked on the development of the GM Oil Life Monitor. This was a really good project. It was one of those things that was really technically fun, but when you actually get to a point where you can get patents and applications, that's even better. We had the chief engineer of the Corvette wanted this, so he gave us 2 vehicles to do testing on, which I really enjoyed. But we did, like I said, it found its way into the vehicles. It's been in most GM vehicles for a whole bunch of years now. And what that's typically going to tell you, the real good point to change your oil in any given type of service, compared to what the Quick Lube says, 3,000 miles, we figured this device has saved as much as 500 million gallons of oil since its inception. So that's really a cool thing when you think of it that way.
Hey, Don, I hate to interrupt, but the slides I'm seeing are only on, we're still on the title slide. I don't know if you're changing slides or not.
Okay. Sorry about that. You got it now?
There we go. Yep. Okay.
Yeah, okay.
Degrees Co-op. Yep.
Okay. Sorry about that. So working on the GM Oil Life Monitor, that was really neat, for that reason. Then I had an opportunity to do a specialist assignment in the GM Research Executive Department, a broadening experience where I was kind of a gopher for the directors and the vice president of research. I did have one kind of fun job for that. When VIP was coming to visit research, I usually met them in the lobby, brought them in, got them a coffee, got them situated, and you met some pretty neat people. The neatest one I remember so clearly was a senator from Ohio who also happened to be an astronaut. Yeah, I got to meet John Glenn, and I got a thank you letter from John Glenn. So that's one of those, hopefully sometimes during your career, you get those little perks that are just really cool. At the end of that assignment, I returned back to fuels and lubricants, but at that point, GM was starting to focus a lot more on the manufacturing process. So they asked me to run a group and to work on plant lubes. And I spent a lot of time visiting the plants, understanding the problems, engaging the plants, and we developed some pretty good tools that we thought would be useful for them to use. So I went to the executive director of GM Worldwide Facilities and pitched some of these tools in a presentation. And halfway through, he said, "Stop." And I'm like, "Oh boy, that's not good." Well, actually, it was good because he says, you don't need to sell us. We want this. How do we get it done? And in typical GM fashion, they get kind of stuck for about 6 months or so. And it was a happenstance, a lucky call. I received a phone call from a GM exec. And this is a guy who I knew because when I was president of the Engineering Society of Detroit, he came on the board and I helped him get up to speed with, the people, the hidden agendas, the whole thing. And he would call me occasionally with some ESD issue, and that was this. But he also was the boss of the executive director at Worldwide Facilities. And I mentioned that I wanted to go to work there, but we got stuck. And and he made it happen. So sometimes you have to kind of go in through the back door. I was really working there in an environmental area. And my second week on the job, the director came in and said, "Hey, you're leading the used oil program." And it was a deer in the headlights look I gave him, because that was I was there 2 weeks, and now I had responsibility for 18 million gallons of oily water. But I did have a lot of good people. I engaged a lot of people. One guy was the Willow Run waste treatment guy. He had 8 million of the gallons, and I remember having a heated 45-minute conversation with him. And at the end of it, he says, "I don't particularly like what you're telling me, but I feel like you've been honest with me, and I think I can work with you." And I begged him to be part of my program, and things went really well from that standpoint. And we were able to bring back about half of what we used in the plants was either re-refined or recycled engine oils or oils. I also worked in indirect chemicals management. Indirect chemicals are things that are used to make the vehicle, but they don't leave with the vehicle. And they're typically commodity type items, and there's a lot of fluctuation in price. And sometimes the suppliers build a lot of hedging if prices are really fluctuating. And I went and I worked with purchasing, and I introduced them to indexing, where they could look at the price of, say, a hydraulic fluid in the plant is going to be very similar. That cost is going to be very similar to solvent neutral base oil that's in a published index. So what they could do is make an adjustment every 6 months based on what that given index did. And it turned out to be much fairer for both parties. I then returned to GM as a manager to GM Research R&D, and did that for a couple of years and some interesting projects. But then I took a retirement from GM, and Evonik Oil Additives USA found me and offered me a job as the OEM liaison manager for North America. And I said, well, basically, what does that job do? We develop relationships with the automakers and understand their technical needs. So I said, well, I'm calling on people like me, my friends in Ford and Chrysler. And it's like, yeah, okay, that's pretty easy because I know most of those people. I also managed fuel economy programs for Evonik in both the US and Germany, and that was a lot of fun. A lot of interesting stuff. After 5 years, I retired from Evonik, and I formed a limited liability consulting firm, Strategic Management of Oil. I did pretty well for a couple of years, and then COVID kind of killed it. But I just got some more business, and I actually have a meeting on Wednesday of this week. So it did come back around finally. Couple recommendations that I could say based on my career are, if you have a chance to do a co-op or an internship, absolutely do it. There's the two outcomes, and one is that you get really fired up because you understand what you're learning in college is going to be used for, or you go, oh my God, I don't want to do that the rest of my career. And either one is a good thing to it's a good thing to understand. Hands-on project, things like the SAE, those things are great because you got to be resourceful. You're not getting a kit where you're putting things together. You got to go say, oh, I got to go find a machine shop or this or that. That's all part of being a good engineer. You'll get training specific to your job from your supplier, but the professional societies like SAE are a good place to get some more training. Use your professional societies for networking, absolutely. I don't know that I ever would have gotten my move from research to worldwide facilities if I hadn't known one GM exec through the Engineering Society of Detroit. Just some free advice that I'll give you, and free advice is worth what you pay for it. I would say always ask a lot of questions. They always say there's no dumb question. I think the dumb question is the one that's not asked. It's more productive and usually more fun to be somewhere else than your desk. When I was doing the plant loops, I was in plants all the time, and I love going to plants. You see all this stuff coming in different doors, and it all goes out as a vehicle. It's pretty amazing. Keep a sense of humor. I think that can help diffuse a difficult situation. Don't be ashamed to be a nerd. I mean, we're engineers. People tend to think of us as nerds, but we're the ones that get things done. The breadth of experiences, I think, can be more important and useful than the depth. You could be the world's best expert on some very small area, and if that goes away, you're kind of screwed. But if you've done a bunch of different things in your career, like I have, and that's a good thing. If you can do a lot of different jobs without even leaving the company, that's really great. Forget the comfort zone. Life's a lot more exciting, can be terrifying sometimes out of it. Certainly, when I got that used oil program, that's one of those things where I was like, oh my God, how do I do this? And also when I was, traveling to see the DOD and the FBI and all that, but you really grow when you're in that position. Look for a way to give back to the profession. And that's why I and people are here today to help the students give something back to them. Couple more things finally. People are more important than projects, no matter what. At the end of your career, you're going to find all the stuff you agonized over day in and day out. It's going to go away. And what remains are the friends that you've made along the way. And finally, recharge your batteries, find time to laugh, play, and relax. And that's what I had. And thanks for listening.
Well, thank you, Dawn. That was great. Thank you so much. Yeah, one other thing I wanted to leave with you guys too is if you are going to be graduating soon and you want to get involved with the program, please reach out to me. You guys have just went through it, and I'm sure you could be great leaders in the program too, just like these three that are here with us today. Anybody who's on here, Rebecca Volman will be doing a chat with the expert later today, I believe at 1 o'clock over on Connection Plus. And she is one of our industrial lecturers too. She will be speaking on the value of diversity on your team. So you could check that out. If you aren't able to, it'll be recorded just like this is, and you can catch it later. Now I'm going to turn it over to Amanda just briefly. She's going to talk about the SAE, the section speaker series that we have also. So let's see here. All right, can you guys see my screen? No? Brittany?
Yes, and I don't know if you saw in the chat that Connection Plus is actually at 12.
Oh.
So here shortly.
It's
Oh.
Eastern.
Okay. So,
Yes.
okay.
But there is your screen.
There we go. Okay, thank you. Yes.
Thanks, Britt. So you guys already kind of touched on the sections a little bit. So we do have our local SE sections throughout the U.S. and abroad. So we also have a program that's similar to the industrial lectures, and that is the section